Welcome back, grade fives, and congratulations on being done the Math 5 curriculum over a month early. That is crazy. So what I want to start doing for you guys is introducing a math skill, a new one every week that we can work on for that week. And these are going to help you for the rest of your life, really, but they're going to help you with future math concepts that you learn. So the math skill that we're talking about this week is factoring. We scratched the surface of factoring in our multiplication division unit, but we didn't really do factoring. At least not like this. We didn't do factor trees, but you guys already have the skills you need to learn this skill. Like you can, math kind of builds on itself. So you need this skill to learn this skill to learn this skill. You already have all of the skills you're going to need to do really well at factoring, which is multiplication and division, but we haven't seen it. So let's take a look at it. If I have a number, say 20, I'm going to put it in a circle. And factoring is all, sorry, that's a terrible circle. Sorry to get sidetracked there, whatever. Factoring is all about division. There's a little bit of multiplication in there too, and you'll see that. So what I want to do is think, is there any number I can divide 20 by to break it up basically into two numbers? So what can I divide 20 by? Evenly, so that there's no remainder. Well, there's a lot of numbers that I can divide 20 by, right? First off, I'll show you. I don't want to divide 20 by, say, 9, because 9 doesn't go into 20. Right? If we're multiplying 9, 18, 27, we never hit 20. And so 20 divided by 9 would give us a decimal answer, right? It would be 2 point something. And so that's not helpful. What we do want to divide 20 by is any number that is going to break it up evenly. Okay? So for example, I could divide 20 by the number 4, right? 4, 8, 12, 16, 20. 4 goes into 20 5 times. So if I were to divide 20 by 4, the other piece would be 5. So when I'm factoring, when I'm making this factor tree, the two numbers that split from it, we're always doing 2, and we're not going to do 3. The two numbers that split from it are going to multiply together to get the original number. Okay? Like so. But we're not done here. Can 4 be split up any farther? Is there a number that we could divide 4 by to make it even smaller? Well, yeah, we could divide 4 by 2, and we could get 2 and 2, right? Not so bad, made it even smaller. And you'll notice again, 2 times 2 is equal to 4, which is the number that it came from, right? So that's just how this factoring works. Every time we're just dividing into numbers that multiply to get to that original number. Okay, so we've split 20 into 4 and 5, we split 4 into 2 and 2, and in a sense, we split 20 into 2, 2 and 5. Can we go any smaller on any of these numbers? Okay, so 4 is already split up. We're just looking at the bottom of each tree. So this number, and this number. Can any of them get any smaller? Well, let's take a look at 2 first. Is there anything we can divide 2 by to make it smaller? We could divide it by 2 and get 1. Okay, let's try that. But if we do that, we actually end up with 2 and 1. And you'll notice we didn't make 2 any smaller. Even though it looks like we did over here, because 2 is still one of our factors, it's still included. So that doesn't make any smaller. So we have a kind of a rule when we're factoring. We don't divide by 1, and we don't divide by itself, whatever the number is. Okay? So if those are the only two things that you can divide by, then what you have done is you've reached a prime factor. Okay? So 2 is a prime factor. It can't get any smaller. You really can't. 5. Let's take a look at 5 now. Is there anything we can divide 5 by to make it smaller? We can divide 5 evenly by 5, which is itself. We don't want that. We can divide 5 by 1, which we already said doesn't help. Is there anything else? No. Everything else that we divide 5 by is going to give us a decimal answer. Okay? If we divide 5 by 2, we get 2.5. And we don't want decimals in our factoring, okay? That's not helpful. So 5 is also a prime number, meaning that we have come up with 3 prime numbers from the number 20, okay? Even though 2 and 2 are the same, we still have 3 different prime factors, because if we want to create the number 20 from our prime factors, we have to say it is 2 times 2 times 5. All of our prime factors, I'm going to underline them again here with maybe a different color. All of our prime factors, 2, 2, and 5, when we multiply them together, are going to get our original answer, which is 20. That's how factoring works. Whenever you get to the bottom of each chain, You multiply your answers together and you'll get your original number. So this times this times this, all the way back up to the top. Okay? Let's try one more time with a different number. Let's try, let's try 16. Okay? And I'm actually going to do 16 two different ways and see if we get the same thing both times. Okay? So 16 could be divided by 4, right? That's one thing we could divide by. And if we divide 16 by 4, what do we get? 4, 8, 12, 16. 4 times 4 is 16, so we're going to put that there. We saw in our previous video, and you should know anyway, previous video, sorry, we saw in our previous example that 4 can be split into 2 and 2. And we also know that 2 is a prime number, so we're going to stop there. And we're going to split this 4 into 2 and 2. So our prime factors are 2, 2, 2, and 2. 4 2's, okay? So that's important. Now let's take a look at our other side. I said I was going to do it a slightly different way. So what if instead of dividing by 4, I divide by 8, okay? 16 divided by 8 is 2, okay? I already have a prime factor up here, so I'm going to star that one and not go any further. But the 8 needs to be split up. I could divide 8 by 4 and get 2, okay? And then I could divide 4 into 2 and 2. Okay? And then I have a 2 here, a 2 here, a 2 here, and my 2 up here, meaning I got the same answer even though I went a different route. My 4 prime factors of 16 are always going to be the same, no matter which tree you make. No matter what you divide by at the start, you're always going to get the same answer. So the prime factors of 16 are 2, 2, 2, and 2, no matter which way you do it. Okay? So don't worry about picking the right number from the start. As long as it divides, you're always going to end up with the same 4. Well, I'm sorry, not always 4. You're always going to end up with the same prime factors. Remember, the first one didn't have 4. Was it 5, 2, and 2, right? It only had 3, even though it was a bigger number. So how many you have doesn't matter, but you're always going to end up with the same answers. Okay, for today, I'm going to just give you one question. I want you to try it on your own. I want you to take the number 24. Well, that's a bad circle. It's a little better. And factor it. So make a factor tree just like we've been doing in this video with the number 24 and write out all of your prime factors at the end. Okay, what do you get? How many are there? And if you're feeling ambitious, try doing it another way, because there's more than one way to factor the number 24, and see if you get the same prime factors. If you do, that's probably a good indication that you did it right. All right, that's it for today, grade 5s, but look forward to the video tomorrow, which is going to show you the factoring game.